Welcome everyone. So today we're going to discuss about conservation laws in classical mechanics. In physics, a conservation law states that a particular measurable physical quantity of an isolated physical system remains invariant or doesn't change as the system evolves over time. So there are many conservation laws in classical mechanics, and we're going to start with the conservation of linear momentum. And the conservation of linear momentum in classical mechanics implies the homogeneity of space. So first we're going to discuss about the homogeneity of space. Now the homogeneity of space. So the homogeneity of space implies that the physical laws are invariant under space translation. So if we change the position of every particle by the same constant vector epsilon, the Lagrangian of our system would remain the same. So mathematically what it implies? So mathematically it implies that if we change Ri to Ri prime, that means if we change Ri of every particle, position of every particle Ri by a constant vector epsilon. So if we change Ri to Ri plus epsilon, then the Lagrangian L of the system would remain the same. This is the main concept. So when Ri tends to Ri prime, which is equals to Ri plus epsilon, the change in the Lagrangian of our system, which is delta L is equals to summation I del L by del Ri dot epsilon, or epsilon dot del L by del Ri summation I. So this symmetry under arbitrary translation implies delta L equals to 0. That means the change in the Lagrangian delta L is equals to 0. Or summation I del L by del Ri, this term is equals to 0. So using Euler-Lagrange equation, this implies d dt of del L by del Vi is equals to 0. Now for a closed system, potential energy V depends only on position of the particles. So L Lagrangian is equals to half summation I mi Vi square, that is kinetic energy, minus V, which is function of Ri. Now we then get d dt of summation I mi Vi is equals to d dt of summation I Pi is equals to 0. Cos delta L is equals to 0, and from our previous calculation we get that d dt of summation I mi Vi is equals to 0, or this is our momentum Pi. So the total momentum of the system is constant. So in case of homogeneity of space implies the conservation of linear momentum. So the homogeneity of space implies the conservation of linear momentum. So this was our discussion on the homogeneity of space, and on our next class we are going to discuss about the isotropy of space. Thank you everyone.